Hi everyone, my name is Shankhadeep Baul and I am a second year PhD student in the Earth and Environmental Science department. My research is focused on mid-Cenozoic loess deposits of Western United States. Here I present a brief comparison between the mid-Cenozoic loess and the late Paleozoic loessites to understand the climate conditions that generated abundant silt grains and strong wind systems. The three major points of comparison are the effects of global climatic and tectonic events, which aided to the favorable conditions for the lowest formation, and also the mechanisms which provided the large amount of silt. Here's all the locations of the reported lowest deposit divided in three different maps of different time period. This one is a map for the lowest deposits of quaternary period merged with aridity index. These two are reported lowest deposits from mid-Cenozoic and Paleozoic period. So continental acidification has long been correlated to the lowest deposition in the geologic past. In this map, we can see quaternary loess is predominantly found in semi-arid regions of different continents where the aridity index is relatively low. However, there are multiple major tectonic and climatic events which affected the global climate in the past. In this figure, we compared the oxygen isotope records, global change in sea level, and changes in CO2 amount in the atmosphere. On the right two columns, the major tectonic and climatic events have been marked. So if we look at this timeline, the deposition of this mid-Cenozoic loess in western US starts just before the global cooling of the Eocene-Oligocene transition at around 32 million years ago. It was likely recycled from fluvial sediments with major portion from concurrent volcanism in western and southwestern North America. This loess was deposited partially because of continental acidification induced by a rain shadow development related to the renewed uplift of the North American Cordillera. However, unlike most of the quaternary loess, no major glacial mechanisms contributed to the silt. Rather, the fluvial mechanisms can be considered as one of the major mechanisms contributing to the silt generation for this one. Lowest deposits of similar time has been reported in the scenic basin of western China. It predates the lowest of western USA by approximately 4 million years. The uplift of Tibetan Plateau and the change in paleoclimate driven by the retreat of the Paraethes has been considered as one of the major driving factors behind the lowest deposition in Asian interior during the mid-Cenozoic. Now, if we take a look at the major tectonic events of this time, we can see that the opening of the Drake and the Tasmanian Passage and the decline of a global PCO2 values, all of which are related to global cooling at that time. All of these have contributed to the formation of lowest deposits at different parts of the world. Now, let's go back to the late Paleozoic period, which is here at around 290 million years ago. The late Paleozoic loessites in the Pangaea supercontinent was deposited in the equatorial area. The collision between two large land masses formed the Central Pangaean Mountains in an enormously large continental interior in the mid-latitude region. This enormous mountain system blocked moisture from oceans, causing acidification and lowest deposition in the western France. Also, this loess coincides with another cooling period, the late Paleozoic Ice Age. The uniqueness of this loess lies on the fact that it was deposited very close to the equatorial region. The glaciogenic origin of the silts in the Paleozoic loessite raises a question about the occurrence of the glaciers in the equatorial region based on the location of these deposits at that time. So, to conclude the presentation, I tried to summarize this comparison with this table. The Quaternary loess, Mid-Cenozoic loess, and Late Paleozoic loessites all occurred during a major global climate cooling period, while the Late Paleozoic loessites and the Mid-Cenozoic loess were mostly driven by climate changes induced by tectonic uplift and land redistribution. The Quaternary loess deposition was driven and enhanced by global climate cooling. This is a brief summary of this comparative study. Thanks to Dr. Fan for her relentless support, and also to our ever so lively department for making our life a bit less stressful. Thank you so much to all of you for watching.